Atomic mass and the average atomic mass. Atomic mass is a very fundamental property of an atom, and we cannot use the conventional units like kgs and the grams to weigh measure the mass of an atom, because atom is a very small particle. So we use a different unit here, which is called as an atomic mass unit. In terms of AMU, we measure the weights of atoms in terms of AMU. What's AMU? What's atomic mass unit? Atomic mass unit is one atomic mass unit is defined as a mass which is equal to 1/12 the mass of the carbon-12 isotope, right? So that means if you have a carbon-12 isotope, 1/12 the mass of that carbon atom is the 1 AMU, correct? We take here carbon-12 as a reference, and with respect to this reference we measure the weights of other elements, and whatever is the mass of this carbon-12, 1/12 of that, right? 1/12 of that, one atom of a one carbon-12 isotope is a 1 AMU. To understand it, let's take an example here. If this is a carbon atom over here, and if I cut the carbon atom into 12 equal parts, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The weight of the one piece of this, the carbon atom will be equal to the 1 AMU, right? That means one atomic mass unit is the mass of the 1/12, the weight of the carbon-12 isotope. And in terms of kgs, how much will be this 1 AMU? It's a very small unit, but if you want to express in terms of kgs, how much it is. In terms of kgs, 1 AMU is 1.66 times 10 to the power -27 kg. You can see how smaller unit it is. So we measure the weights of other elements with respect to this the reference carbon-12 isotope here. Hydrogen atom, we know its atomic number is 1 and atomic mass is also 1, right? So that means the mass of the hydrogen atom over here is exactly equal to 1 AMU. Sodium atom, we know its atomic mass is 23, and oxygen, we know it is 16, right? And nitrogen, we have the 14 there. That means the sodium, its atomic mass is 23, which is 23 is the AMU atomic mass unit, which means that sodium atom is basically 23 times heavier than the 1/12 the carbon of the 12 isotope, right? The weight of the 1/12 the weight of the carbon-12 times 23, that is the weight of the sodium atom. So oxygen is 16 times heavier than this piece of a carbon atom, right? Nitrogen is 14 times heavier than this piece of a carbon, 1/12 the weight of the carbon-12 isotope. But you will see that in the periodic table, most of the elements, their atomic weights, atomic masses will be given in terms of not in the whole number ratios, it's in the fractions, right? It will be there in the fractions. Like suppose you will see the chlorine has an atomic, you will see in the periodic table, its atomic mass will be something 35.5. But how is this fractional value? Basically, for those elements, the atomic weight is we are taking there the average atomic weight, right? So this weight that you see here in the periodic table in the fractional values, normally it is basically the average atomic mass. It's not the atomic mass, but we take it as a average atomic mass. How is this average atomic mass different than the atomic mass? We know that certain elements, they exist in nature as isotopes. And what are isotopes? Isotopes are the elements having the same atomic number but different atomic masses. Different number of protons are there. Suppose we have chlorine, which is present in the in the two most important isotopes. Chlorine, atomic number is 37 and another one is a 35. So these are the two isotopes of the chlorine. So we have a chlorine with atomic mass 35, right? Atomic number is 17 there. We have another isotope of the chlorine, which is chlorine, that is 37, and again atomic number is 17. So that's why these are the isotopes, same atomic number, different atomic masses. And what we see in the nature, the natural abundance is different. You see that this is chlorine 35, it is 75% in natural abundance, and this chlorine 37 is only 25% in natural abundance. That means the ratio will be here, you can say 3:1. And if you want to find out the average atomic weight, right, average atomic weight of the chlorine here, average atomic mass will be equal to the the atomic number, atomic weight of this chlorine, which is 35 here. The isotope, one of the isotope is 35, another one is 37. So 35 times its natural abundance. The ratio is 3:1. You can take it in terms of ratios also, or you can times it in terms of percentage. So let's take it in terms of the ratio here. So a simple whole number ratio is 3:1. So I can say 35 times 3 here, whatever is the ratio here, right? Okay, 3 plus, you can say we have another isotope which is 37 times 1 over here, and divided by this number over here, 3 and 1. So that means 3 plus 1, the sum of those values here, that is 4. So when you simplify this value over here, what you will get, 35 times 3, 37 plus 37 into 1 divided by 4. So when you solve it, it comes out to be 35.5. So we can say that this is actually the average atomic weight of the chlorine, right? Atomic number is 17. Average atomic weight of the chlorine is 35.5. That's why you see the fractional values there. Okay, let's take one more example over here. We have copper with the atomic number 29, right? We have a copper in the atomic number is 29. So copper with atomic number 29, two most important isotopes of the carbon are, one is 63 carbon, copper 63, another one is copper, that is 65. And their natural abundances again in the form of it is 75%, and this is 25%, right? Okay, and you can say it is a 3:1 ratio. And again you can use the same formula, right, to find the average atomic mass, right? Average atomic mass will be, you can say it is copper with atomic weight is one of the isotope is 63, right? Atomic weight is 63 times it is natural abundance 3, and plus another one is 65, right, times 1 divided by these values here, 3 plus 1, that is 4. And when you solve it, it will come out 633.5 AMU, right? This is the average atomic mass of the copper. That's why you see this value here for the copper in the periodic table will be showing 29, the atomic number, but the atomic weight will be 63.5. You can also simplify it like this. You can also solve the same question. Rather than taking this ratio here, let's talk about the percentage in terms of percentage also, right? That's also the same thing. 3 times 63, or you can say it is 63 times the percentage, 75 over 100. Correct. Plus what else is there? We got here another one which is copper to 65 times 25%. Okay. So that means which is when you solve it, let's solve this one. So this will be equal to 47.25, and this will be equal to 16.25. So when you simplify it, it will be, when you add the 2 here, so it will be 633.5. So you can find the same answer two ways. Either you take in the whole number ratio right here, the natural abundance, or you talk about in terms of percentages also. Correct? Hope you got it. Thanks for watching the video. Bye for now.